Why is nothing working? I've just restarted it, but my thing is not working now. I mean, they can see it, but it's not.
No, why? Why is this different?
I can't actually move my.
Why is this screen different?
It's what I'm doing now, but I can't see my. I can't. My Chrome's.
Your what?
The Chrome window has frozen, except it's not frozen there. I'm just going to have to quit it.
Oh.
Nope, not today. It's not frozen here. It's frozen there. Beautiful. Let's try this again.
What are you going over today?
Pardon?
Erase?
Erase today. Yeah. Why does nothing want to work? Can you tell me that? I'm pressing on it, right? Where is it?
Maybe try like Microsoft Edge.
It's not here. It's not in another desktop, is it? Oh, people can see my desktop now, so that's good. Yep, hope they enjoy that. Why isn't it showing this? Why is it showing that? Oh my god, is it extending? It's mirroring. Oh my, it's... What's this? This is what's happening. It's doing, it's screwing this up.
Maybe you have...
It's mirroring, it's not mirroring my... It's using it as a separate display. There you go. I can't actually handle this. I'm so done with this ridiculous...
Oh.
There we go.
Alright. I don't know.
Well, I don't want anyone to see what I'm doing now. All right, let's try this again. All right. I don't think this is that working? I can't, okay. What? Yeah, this is what you should see, I think. I'm not having a good time today. So much for being able to write today. All right, let's start. All right, let's get started. That was a really bizarre start, actually. I didn't look for it to start like a function cell pass situation. Ah, very good. All of the above. Oh, messing with you. That feels like messing with you. Got real quiet all of a sudden. Nice. Oh, I didn't mean to skip over that, sorry. Okay, next one. Oh, yeah, no, functions are just, all right. You do not need to import a library to be able to use functions. They're just a way that we structure our code when we write it. Interesting. All right, next one. Not bad. Yep, one was an int, one was a double. All right, nice. Nice. Good job. All right, almost to the end. What happened there? All right, so you go into main. You declare x and y 3 and 7. You declare result. You make it equal to 0. Then you call the function sum with x and y. So you send it with 3 and 7. So over here you've got 3 and 7. Then over here you've got the result and you're adding it together. So 3 plus 7 is 10. Then you return that 10, but it's stored in nowhere. So then you go into the printf statement, and these two numbers, x and y, are still 3 and 7, but the result is 0. It's the one from this function in here. Okay, let's see the last one. All right. That was my bad. That should be 30. No, wait. So 5, 6. Then you're calling the function something with 5 and 6. Oh, then you're making x equal to 4 in here. So it's going to be 4 times 6. 24, and you're returning the 24. So it should be 24. Not my bad. I did it. Okay. It should be 24, so 30 incorrect. All right, let's see who came out on top. Aditha, get ready to chuck some stuff. Here we go. Don't know how to pronounce that. Who's come number 1? Oh, what a great name. Not even standing up. My goodness. You're going to have to move. I don't know. Just throw some out. Someone's raising their hand. Pretend like everyone's a truth teller. Aditha, just throw some out. Just go crazy. Okay, someone. All right. How is the volume out the back? Is this? I don't actually know if this microphone is even doing anything.
Lovely.
It's lovely. Thank you very much. Someone online doesn't think it's lovely. Oh, that person's in person. Okay, great. Okay, so apparently this is the only microphone that works in this room right now. So either I project my voice or you're stuck with this volume. Okay, so on Monday we talked about style and we also talked about functions. And your feedback was 10 people thought I went too fast, and 10 people thought I went too slow. So it's very difficult to find a happy medium. Just keep letting me know what you think, and then I'll go with whoever wins. This time it was a bit of a stalemate. Today we're going to look at arrays. I had these, feverish dreams that we're going to go to strings, but I think that's not going to happen. I think we'll do strings next week. So we're just going to do arrays, and then we're going to do functions with arrays to practice our functions. And that means I don't really have to recap functions now. We're just going to do them as part of arrays. So what I'll do is I'll skip over the function stuff, the recap, and then we'll do arrays to start with. And then we can talk about functions in the context of arrays. Okay, so in this course you're going to learn arrays as a data structure, which is what we're going to start today. Exciting. And then you're going to learn linked list after Flex Week with the lovely Tammy, because I'll be gone for some of it at a conference. There are other data structures, but you don't learn them in 1511. You will learn them as you keep going through your computing degree, so lots of things, to choose from. And then when you have to choose the kind of data structure that you want to use in your programming, it really depends on the context of the problem, what you're trying to achieve. In 1511, we don't care about wasting memory and time, so we don't really care. But as you go on, you'll learn about, data structures, making a difference to how efficient your code is as well. We just don't really care about efficiency for now. We just want to give you the backbone of how to program to start with. So, arrays, how exciting. Who has done arrays before? Oh, quite a few of you. Who has done arrays in C? Oh, gosh, okay. A few of you yet again. Well, yeah, exciting. So arrays are a data structure where we store things all of the same type, okay? So imagine if, I want to store, everyone's marks, how they did in the Kahoot quiz. I want to see how many they did right or wrong. If I didn't have an array, I might need to have however many variables going, which would make the code absolutely hideous. And also changing and manipulating it would make it a lot harder. And all of it is the same type. I would just have an int for all of them because I'm trying to keep a score of what each one of you scored. So an array comes into it. Array is a structure where we kind of hold an array of all of the same thing. So it becomes a collection, and it ensures that we can access things very easily because we can just call an index of whichever part of the array we want to access, and there it is, voila. And we can change things very easily. Now in arrays, it's not that easy to add things to it if the array has run out of space, because you kind of define what size the array is going to be, and at compile time enough memory is given to that array. But it is a data structure that is available to us. It's very good for when we know the exact number of things that we want to store. And if we don't, usually we end up wasting a lot of space. Again, don't care about it in 1511, but you will start caring about it as you go on in your other courses. All right, so let's say, and we'll do the theory first, then we'll go. I tried so hard to bring my iPad to draw on it today, but it looks like the screen will only let me mirror one thing, which is very, very annoying, but I'll still try and draw as much as I can to show you what it's doing in the code. So let's say I'm going to record the number of tea I drink every day for a week. That's, I don't want to have 7 variables for that. I would just have an array, and then each index of the array stands for each, time that I'm drinking tea, which is quite a lot. That's where I get my caffeine fix. What about, daily temperatures for a year? Again, I don't want to have 365 variables. I'm just going to have an array to store all that. Amount of time daily that I spend walking my dogs. Some other examples. What are other good examples of where I would want to use an array? Yeah?
Weekly grade.
Weekly?
Weekly grades.
Yeah, weekly grades, absolutely. Yeah.
If you needed to do mathematical operations, you might use them to store particular mathematical things like vectors or matrices.
Yeah, absolutely, I might do that. That's a much more complex example. Yeah, but yeah, Absolutely, yeah. Attendance, yeah. Not that I'd ever subject you to measuring your attendance. You're at uni now. You're in control of your own attendance. Yeah, so lots of examples of when we want to group things together. So one way to think of an array is, let's just pretend that it looks like this, okay? And what it looks like in memory is that it's contiguous, which means that each one of these comes after another, comes after another, comes after another. So we know where everything is stored in memory if we know where the first thing is, and we know the size of the array because we know that it just comes one after another. They're not randomly positioned in memory. It's all as a big block of memory. Now what that means is that we can randomly access whichever index we want because we kind of know where they are stored in memory. And they're stored together. So let's say I'm doing my tea consumption for a week, and that means I want to have, I want to store 7 integers. And that means an array is created that has, and this is kind of visualizing it, but obviously that's, yep. So it's got 7 indexes, and you notice it will go from 0 to 6. So we always start at index 0, and one-off errors are really, really common when you first start to program, and it's usually because you try and access index 7 because there's 7 days, makes sense, you want to access the 7th, but there's no such thing as index 7 because it starts counting at 0. And you can access any of these elements by referring to whichever index you want to actually access. So let's say I'm doing this tea consumption for a week. I'm doing it without arrays because, I don't know, I've got a lot of time to waste. I peaked on Friday with 7 teas. I've got in Monday and Tuesday, in Wednesday, Thursday, blah, blah, blah. And then I'm kind of trying to say, all right, any day with 3 or more, too much tea. And, you know, I'll have to do if Monday is greater than 3, or if Tuesday is greater than 3, or if Wednesday is greater than 3, or if Thursday. So you can see that it's not just the number of variables that I've declared, but then doing any manipulation of those variables or any checking of those variables becomes very tedious. Also very, very bad code. So I really want to be able to do it much easier. Arrays. So if I'm going to declare an array, what I will do is I will say what type of data that array is holding. And remember, each index of the array or each element of the array has the same data type in it. So when I'm declaring an array of type int, that means that every single thing has an int in it. And that's how I know where it is going to be in memory. And so if you remember in structs, when we did structures, we could hold a bunch of different things all together. We didn't really care if they were the same type. So it's quite different to an array where everything is the same type. So I will declare the type of data that's going to be stored in it. I'll give it a variable name. And then I'll use these lovely square brackets, which says that it's going to be an array. That's what's saying it's going to be an array. And I will give the size of the array in there. So I'll show you in the code. That's not the only way I can declare an array, but it's one of the ways. So I'll specify the number of things in the array. Now, if I want to declare and initialize the array, I will kind of do, okay, I'll declare it. So I'll say what the array is. I'll say what the size of it is, 7. And then I'll do an equal sign, curly brackets, and then I'll do what actually goes inside that array. So you cannot declare an array on this line, how we can do with normal ints. I could say int numbers equal, int number, semicolon, and then I can say number is equal to 3, and that will assign the value 3 to number. I can't do that with an array because if I declare it on one line and on the second line I try to say tea drinking, you know, square bracket 7 is equal to blah, it's not going to happen because all it's doing is trying to access the 7th index, which also, by the way, does not exist. So it's not going to work for you at all. So either you declare and initialize all in one foul swoop, or you declare that you're using an array and you initialize it from user input or in any other number of ways, really. Okay, so let's say we have this array here and we've initialized it. So we've declared that it's of type int and it's called tea drinking. There are 7 things in it, which means the indexes will go from 0 up to 6. And these are the values that are stored in my array. And you will note that they'll go, so 3 will be at index 0, 2 will be at index 1, 1 will be at index 2, I chose the worst numbers, 2 will be at index 3, 1 at index 4, 3 at index 5, and 5 at index 6. So the array holds all of those things in it, and it now means that I only have one item that's storing all of my values, so I don't really need to have 7 variables. I can access any element of that array by referencing its index, which means that if I want to access something at index 2, so I want to have, the third value of this array, I'll just say, okay, I want the name of the array, which is tea drinking, and then in square brackets, which index I'm interested in. So in this case, index 2, and that will give me what is stored inside this array at index 2. Now, if I try to access an index that doesn't exist, it will obviously result in an error because you're just trying to access something that is not there. So there is no index 7 in this case. Okay, so for that same reason, you can't really printf a whole array, but you can print out each individual element, because every time we access something with those square brackets, we're accessing a single element of that array. And you can't scan something in, and again for the same reason, because you can scan one single element but not the whole array. So how do you think we could do it for the whole array if we were to print it out or to scan it in? What do we reckon? Yeah, a while loop. We just traverse through the array from index 0 to wherever it finishes, and we either print it all out or we scan it in, depending what we're trying to do. Okay, and here is the lovely while loop. So let's say, I know it's so exciting. You can loop through an array. You can do so many things. Computing, it's where you all want to be. I hope that is actually where you all want to be. Otherwise, this is going to be a very depressing 3 years for you. All right, so our array in tea drinking, there's 7 elements in it. We've initialized it to those values. Fantastic. And then you're going to get nightmares, I guess. This is going to be a loop on repeat. So int I is equal to 0, and in this case, you're allowed to use i's and j's when you loop through an array. You don't have to call it anything else. That's a fine variable name, even though it's just one letter. I index, maybe. Yeah. I cannot hear that question. I'm so sorry.
Do you declare it inside or outside the main?
Inside the main, okay? So anything, so we always think, unless we're doing it in a function, then we declare it in that function. Great question. Okay, and then we start looping. So we've initialized our loop control variable. Okay, the louder you talk in the theater, the more people can't hear, and the more the people online can't hear as well. Please, if you want to have a chat, it's not a problem, but go out and have a coffee. I remember when I was at uni, I was actually kicked out of a lecture theatre once. They told me to go and have a coffee, so I'm doing it now 20 years later, and it's awful to do that as well. Okay, so we're going to loop through whilst I is less than 7, because we've got 7 things in this array. So we're going to go less than, not equal to, because there is no index 7. So that means we want to stop when it gets to I is equal to 7. We don't want it to actually access at index 7. We're going to print out %d, so for the number that we want. And then we're going to specify which index of the array we're actually accessing. So in this case, the array is tea drinking, and then I want it at index I because my I is the thing that's changing and looping through the array. I'm making my way through it. And then I'm going to increase my I to move 1 over to the next index. So basically it's going to start at index 0. So when this code runs, it starts at index 0, I is equal to 0. You'll check, is I less than 7? Yes, it is, which means you'll go into the loop and you'll print out whatever is in this index, because tea drinking at index I is at index 0. You'll increase your index to the next one, which is the next index at index 1. And you'll do the same thing. You'll check, is 1 is less than 7? Yes, it is. So you'll go in, you'll print out the next thing, which is the number 2. and then you'll increase it by 1 over here again. So you'll move on to index 2. Is 2 less than 7? Yes, it is. So you'll go back in. Shouldn't have chosen something that has 7 indexes. You increase the index by 1 again, which means you're going to move over to the third one. You'll check again the condition of the while loop. 3 is less than 7. Yes, it is. So then you're going to go back into the loop, and you're going to print out that number that's sitting inside that tea drinking array at index 3, so number 2. You're going to increase it by 1, which means you're going to move over to index 4. You're going to check the loop again, print it out, increase the loop by 1 again to 5, and then go through it again because 5 is still less than 7. And then you're going to move to 6. You're going to check, is 6 less than 7? Yes, it is. You're going to print it out, whatever's sitting inside at index 6, and then you're going to increase it to 7. And when you go to check the loop condition, is 7 less than 7? No, it's not, which means you're going to break out of the loop without touching anything at index 7, because if you try to access anything at index 7, there is nothing to access. It doesn't exist. Okay, no, it's not time to stretch. It's time to code. Okay, so I was going to do a very simple demonstration here of just declaring an array and initializing it, and meanwhile I'm going to get Gab to do a poll of how we're feeling about the start of arrays before we start coding. Okay, so declaring an array, again, if I want to declare an array of ints, so I would say that it's type int, and let's say it's an array of int, and then in square brackets I have to specify the size, okay? So let's say it's got 8 elements in it. So that means over here, if it's an array of ints, and there are 8 numbers, the indexes are going to go 0 to 7. And that's going to be this one here, okay? That's just declaring it. So again, I can't declare, and then I can't now do this. Blah, 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 because that's only accessing one index, so also an index that doesn't exist. So that's not a legal statement. Either I have to do it all at the same time, or I have to do it as I keep going. So there is a few ways that you can kind of initialize it. I could do something like that. And if I specify that, what that means is make everything 0 in there, right? So it's an initialized array, everything is 0, and that's it. It just kind of adds it in. The other thing that I can do, okay, this is obviously not going to compile in any way because I'm calling them the same thing right now. If I have nothing in here, okay, if I have not specified a size of the array, then I have to initialize it with the number of things that I'm going to put in there. And from this, it will basically compute that it's an array of size 3, okay? But I can't have this. I can't do that. I got to give it a size, okay? Because we need to know how much memory to save for this array block, right? And because it's all contiguous, I need to know how many portions of memory I need to save for me to be able to access them later. So, not this. Okay, so and then if I want to access an array, all I do is, I'm just going to comment these out. I'll say array int, so I'll call by name, and then I'll do a square bracket, and then I access whichever element I want to access. So for example, array int 2, I can reassign a value to it. I can say that's now equal to 3, and that means, I always hate myself for choosing these big numbers. I'm going to do 4 instead. That means that this array is now going to look something like, it's going to have 0, and so that's, so it's going to look like that now, okay, because there's 4 things in it. Where was that, Paul? In love with arrays already? Oh my goodness, it's not been long. You haven't even had a date, nothing. There's not even been one single exercise. You can't be love yet. Okay, good. Excellent. All right, then let's do some more stuff with arrays that will maybe, this is where your love will end. Okay, so let's do some actual fun stuff with arrays as opposed to just declaring and initializing them. Let's actually manipulate and play with them, and maybe also write some functions whilst we're there. Okay, actually, can you see this code? Have I schmodded it? I haven't schmodded it. No, I haven't. Okay. All right. Let's try and write some things now. Okay, so now you can see this piece of code, which is mostly just a lot of comments and a bit of a stub to get us going. Okay, so let's say I want an array with the values 1, 3, 4, 5, 9, 10, 11. And so for the time being, to start with, we won't scan into it. We'll just initialize it ourselves. We'll do it the boring way. And then we're going to do some functions. So calculate product of these numbers, calculate the average, calculate the sum, count the multiples of 3. I don't know, I couldn't think of any other operations. It was late at night. They're all going to be much of a muchness after you do a few. And then we move to harder manipulations that you can do with arrays. Actually, I should have said, we always use ints to demonstrate the first arrays because for some reason, I don't know, ints much easier to understand. You can have an array of doubles. You can have an array of structs. I do have an example of array of structs if we have time today. You can have an array of anything, right? As long as it's all the same thing. An array of char, you can have an array of char. So a whole bunch of things that you can have. Okay, so in this code, I've defined max array as 7. I think here I was trying to say I don't want to have a variable for each one of the things in my array. I really just want to have a declaration of an array that we will use instead of having a variable for each separate one. So these values look like ints. So I'm going to have an array of type int. So declaring it int, I'll be really creative. I'll call it array. And then what I'm going to give it a size 1, 2, 3, 4, 5, 6, 7. How convenient. I also have a hash defined max array that's 7. So I can also use this to define my array. So I can say, you know, or I can use a 7 depending what I'm using it for in the context. And then I'm going to initialize it by giving it the values that I have here. Okay. So that has declared and initialized an array. Size 7, that's all of our array. So what I'm going to do first is I'm going to do it within a main for the first few things that we do. Then I'm going to move them out as functions for the last few things that you do to show you also, you know, functions and to recap functions. Because usually once people get to assignment 1, functions were really obvious in the lecture, and then when they start doing it themselves, not as pleasant. Okay, so again, we were talking before, all we want to do is we want to loop through the array and be able to access every single element of the array traversing through it to print it out. So whilst I is less than, max array, we're printing out the elements. Okay, so I'm going to print out an element. Let's do that %t. And I'm going to ask it to use array at index I. And then what I'm going to do is I'm going to increase my I by 1 so that it keeps traversing through the array. Okay, so let's try running it. And before I do, I'm just going to, so it's not confusing, I'm going to comment out these lines that were there for the rest of it. Okay, so let's save it. Okay, fantastic. I have a random variable here that I prepared. Okay, so let's see it printing out our numbers. Oh, amazing. It's printed out our whole array that we have here. So 1, 3, 4, 5, 9, 10, 11. That was super fun. Should we do it with a for loop instead of a while loop? Fours, everyone? Anyone? Yeah, don't know. That's a yeah, okay, for loop. All right, so that's using a while loop to do this. And when I do arrays, I prefer a for loop because there's no way I'll forget to do something when I'm doing a for loop. So if you're going to use a for loop, you'll use the keyword for. Int I is equal to 0. I is going to be less than max array. And I++ is what I wanted to do. And then what I want to do is I just want to print out whatever is sitting at that index in the array. So if I run it now, and you know what, because it looks really, really ugly, I'm just going to give a new line here. Okay, now we'll compile it again, and we'll run it again, and it's printing it out as well. So, and a for loop just, I don't know, looks nicer sometimes. Okay, great. We've been able to print out our array. Amazing. Now let's do products of an array. Okay, let's traverse through the array and we'll multiply the numbers together and then we'll do a final product. Okay, what do you think we do now? It's always the same with an array. You want to see an array, you need to loop through it. If you want to actually not access a particular index. Okay, so another for loop because we're traversing through it. So let's do another loop. And again, the condition is that I want it to increase by 1. And I do need a product, and that's why I had this lovely variable here to start with. So I've got a variable that I will keep as my product, and I'll keep multiplying things to that product. Okay, so I initialized it to the value 1 because that's going to give me the first thing without getting rid of it, not 0. So I'll do product is equal to product times whatever is sitting at array at index I. Okay, and then if we output whatever that final thing is. Let's see what it gives us. I don't actually know what it should give us, so whoever can do mental maths really quickly. 59,400. Feels right. Okay, so we've looped through and we've multiplied each element to itself. Not to itself, to the product. Okay. So that's another for loop and another thing that you could have done with an array. Okay. What about calculating the average of the numbers? What do you reckon we need to do? Yeah.
We can go through each number, add it to a variable, then at the end divide it by the size of the array.
Yeah, exactly. So I would just go through each number, I'll sum them up, and then I'll divide it by the number of things in the array that are there. Okay. So if we're to do another for loop where we do an average, so 4. And again, I'm going to go to the end of the array, which in this case is at max array. And I'm going to increase by 1 so that to move through the different indexes. Okay, and I need a sum now to hold however many I have. So I'm going to declare a variable sum and make it equal to 0 to start me off adding every single thing, which is actually going to do this one as well, but anyway. Okay, so then I can do sum is equal to sum plus whatever is sitting inside array index I, which will just keep adding them onto each other. And then at the end of this loop, when I come out of it, it means that I've gone through the whole array, and here I can calculate my average if I wanted to. So I'll do int average, and then it's going to be the sum divided by the size of that array. And then I'll print out my answer. Okay, so now the average of the numbers is 6, so I hope that's correct, and there's no mistake there. Okay, so then that one's calculated the average. It's been able to sum, and it's been able to divide by the number of numbers. Okay, fantastic. So now we also have the sum. And now it's also 4:55, which is a really great time to take a 5-minute break before we do one last thing for the arrays. And then we're going to do the trickier array, I think. And yeah, enums and structs in it as well, so that you can be really... Maybe we'll do an array of chars as well. Who knows? All right, let's have a 5-minute break. Sure.
About this Street Fighter.
Oh, hang on. right. Let's go back. Sorry, that was a long break. I was talking to people. Okay, so I realized in my excitement to do arrays, I forgot to actually do functions. And arrays and functions can be quite fun together. And we should really talk about them, because otherwise you'll have your first array function and your mind will be blown. Okay, so let's do a few of these as functions, and then we'll talk about what are the weird things about arrays and functions, what you can return, what you can give it, blah, 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 blah. Okay, so let's do, instead of this printing over here that we're doing all of it inside main, let's move our printing function out to a function. Okay, so if I wanted a function that prints out elements of an array, what do you think what do you think is the output of that function? Will I output anything? Will I return anything, rather? I do output something. No. Was that a no? Was that a no, I don't care? No, I don't, because I'm just printing it out, right? So it's going to be a void function. I don't output anything from it. And then what do you think will be the input to the function that wants to traverse an array and print out every element of it? Yeah. An array. Amazing. Yep. So I would like to give it an array. And then the name, another amazing, I should have been an author, poet. Print array. Okay, so let's write. So return is void, which means that's the first thing that I do. Then I do the name of the function. And then I'm going to give this function something. And what I will give it is an array. Okay, so I'm giving it an int array, and that array is going to be of size max array. Okay, great. Inside here, I want to traverse the array, and I want to actually just print out each element as I go. I'm sorry for all of those that comment that I copy and paste too hard and too fast, but I'm going to copy and paste because as opposed to writing it all out again. So this was the printing function. So what I'm going to do is I'm just going to copy that, and I'm going to comment it out of here so that you know it existed here before but no longer. And instead it's going to go in here. Okay, so now what I need to do is I need to call that function to actually do the printing for me. So I do it the same way, so I call it by calling it by name. So my function is called print array, and then I give it what was the input. So exactly the same way that you've been doing prior to this. Okay, so I'll give it the array, and I referred to it just as the name of that array. So I've called it. Let's see what it does now. Of course. What have I forgotten to do? This is going to be every lecture. What did I forget to do? Why doesn't it know? What does that error mean? Implicit declaration of function? Absolutely. C is telling me I don't know what you're talking about. Please try again. So I'm going to prototype. Okay, and now hopefully that's going to solve that problem. Yes, it does. And I'll run it, and it's printing out, and then it's printing out everything else underneath, obviously, because that's still all there, so nothing has changed there. Okay, so let's do one more of these, and then we're going to talk about returning arrays. Okay, let's do this traverse the array and multiply the numbers together. So we'll do the product. Okay, what will we return from this function? What do we reckon? Yeah. If I print it out in the function, you're right. What happens if I want to print it out in the main, just to be difficult? I just want to return something. Yeah. And I just want to print out the product, nothing else. Perfect. I'm going to return the product, which is an int. So I am being difficult, obviously. I don't have to. I can print it in the function, but I would love to just return something to show you something else. And what do I need to input into this function to be able to go through the array and then do something with it? Yeah, the array, exactly. Okay, so I'm going to give it the array, and I'm going to call it product array. Okay, so we're returning an int, so the first keyword is int, and then the name of the function is going to be product array, and I'm giving it, oh gosh, an int array of a certain size. Okay, and then, apologies again, bit of dizzy. I'm going to copy this. And it's going to go in here. Okay, except now I've told it that I'm going to return something, and I've got nothing to return to it. Also, there are other issues right now. What are my other issues right now? I clearly have many right now. I've got a function, this function saying for int I, that seems okay. Product is equal to product times array. What are my issues? Yeah. Yeah, I don't know what product is because I've gone into a different function. My product is sitting inside main. So I can't have it in main, and it's not accessible by the function unless I pass it to that function. It's not going to be accessible. But really, passing something that's int product is equal to 1 is a little bit of overkill because I don't really need it to be passed along. I can just declare it in here if... Okay, and then what else am I missing? Pardon? Okay, if I want to pass it on, sure. I could say in here, I could define the function that it would get an array, and it would also get an int product. And then over here, where I'm passing to it, where I'm going to call the function, so I'll call the function here. I'm going to give it the array, and I'm also going to give it that other thing that I've said that I'm going to give it. That's how I would pass it along to the function. It would make a copy, and then it would perform its whatever. Yeah. Okay, but we've so far just done it with that, so I'll just do that. Okay, what else am I missing here? Return. Someone said return. I heard it. Okay. I have told it that I'm going to return an int, but in actual fact, I'm not returning anything over here. So I want to return something. What am I going to return? Product. I heard that too. Someone said that. Don't know who. Okay. I'm going to return the product, which means that product is going to travel back to over here. And what's going to happen? Yeah, nothing is going to. I need to prototype this function first of all, and also I'm not saving the return of this, whatever it's returning, I don't have it in here. So instead of declaring another variable, what I'm going to do is I'm going to call the function from inside my printf statement, which means I don't need a product variable. And exactly, I need to prototype it first. Let's do it before I cause an issue, actually. Get rid of this because we haven't honored that. Okay, so let's prototype it. Let's hope I haven't. Oh, amazing. Compile straight away. Okay, and then we think that it's working. We think that the product is 59,400. We hope. Okay, great. Let's do the next one as a function as well. Gab, could you please do a poll? Arrays, functions, how are we feeling? Okay, let's do the average. What's going to be the average? Let's say I want to print it in the main. Actually, yeah. What will I return? I'll return a double. Oh, I could return a double. You really... Even though I'm giving it 2 ints, so that's going to just be something 0.00000. So I suppose I'll return an int just to be difficult. Input, I'm going to input that array that I want to do something with. And I'll call it average array. So the function is going to return an int. And the name of it is average array. And I'm going to give it an int array. That's not what it's called. Max array, the size. So then let's okay, what's going to happen here? What is missing right now? Pardon? Return, definitely. I do need to return something. What will I return? Average, yep. So I've returned something. What else is going to complain at me? Pardon? Yeah, declare sum, exactly. Okay, excellent. So I want to declare sum, and I'm going to initialize it to 0. So now only one thing will complain at me, and that's the fact that I don't have a prototype. Actually, two things will complain at me because I have a sum in my main that I haven't used now. So I'm going to comment it out. I no longer need it in here. And I'll prototype this function. Save. Let's see what it does. Okay, yes, of course. Okay, so the error here is use of undeclared identifier average, and that's because I commented everything out and I've left the word average in here, so it again has no idea what I'm talking about. So what I'm going to do is I'm going to call the function here that actually does the operation, and then it will perform it, and it's going to return the int, which is going to go inside this where the placeholder is for it. Okay, so let's try that. Oh, let's try that again. Okay, I'm really just killing all the vibes here. Here we go, let's get rid of that. So the reason it's complaining now is because I have this sum and I've no longer declared it because I commented that out. So I'm getting rid of that. So let's run it again. Okay, finally, we have success. And if I run it again, it's calculating the average. It's the same number as it was before, so I'm assuming it's correct. Okay, great. So now we've moved two things out to our functions, which means that our main, is, except for all my commenting, is looking really quite nice. All it has in it is just my array, and then it's got some calls out to the functions that I want to use, and it doesn't have much else in it. So now I think let's do this count the multiples of 3 function, and let's do it as a function straight away as opposed to doing it in the main and then transferring it over into a function of its own. Okay, so this function will print out the multiples of 3 in the array. What is going to be my output? Oh, I've got 2 different things. I think I just had a it doesn't matter. We can do this. Okay, so I want to print out any multiple of 3 that I encounter in this array. Let's do it in the function this time. What will I return? Yeah, nothing. I won't return anything because I'm going to print it out in the array. What is going to come into my function? The array. Yep. It's getting very repetitive, isn't it? Okay, and I'll call it multiple 3. All right, so we're returning nothing, and the function is called multiple 3, and I'm giving it an array. Okay, so I don't need to return anything, which is nice. But what I need to do is I need to loop through the array, and I need to check whether whether the number in the array divides by 3, and that means it's a multiple. I'll need to print it out. So I'll need to check if a number in the array it divides by 3, and if yes, print it out. Okay, great. So the first thing we're going to do is we're going to loop through this lovely array. So int I is equal to 0. I is less than max array. And I++, so that we are increasing and updating the variable. And now I need to check whether it's divisible by 3. How will I check that? Yeah, perfect. So I'm going to use the modulus to check whether or not it's divisible by 3. So if whatever is sitting inside my array at index I is divisible by 3, so that means that, so that means that modulus 3 is equal to 0, so there's no remainders, then what I will do is I'm going to print it out. So I'm going to print out whatever is in that array at index I. Otherwise, I'm going to do nothing, and then I'm just going to keep going and keep doing that. Okay? So, okay, what have I forgotten? I've forgotten, of course, to prototype it. This is going to be every lecture. So I'll move up and I'll prototype it here. And what I'll do as well is I'll call it from my main so that we actually see what it's doing. So I'll call the function, so multiple 3, and I'm going to give it the array that I've called it with. So just by specifying the name of the array, you don't need to give the size. Okay, so let's compile it. And let's run it. And should have printed a new line. So it's saying 3 and 9, which is correct. So it's, it's working as we want it to work, and it's doing what we want it to do. Okay, so once you start your assignment, which is going to be actually a 2-dimensional array, which we will talk about on Monday, 2D arrays, which is an array inside an array, because you can have an array of arrays. Obviously, you can even have an array of arrays, but we don't do them here. So once you start that, often people will try to return an array to something, okay? From their functions, they will try to return an array. Who knows if I can do that? Who wants to just take a guess? Who says yes? Jeez, the computers go very strong. That's not even mine. The lectern might die, I'm sorry. That sounded like it was heading for its final rounds. Okay, who says yes, I can return an array? Oh, a lot of people. Who says no? It's a guess. Yeah, you can guess whatever you like. Oh, I love it. You cannot return an array, okay? Not in C. Because an array is... and this is going to this is really ahead of its time in week 5. We'll talk more about it. You'll learn about something called pointers in week 5, which are memory addresses, okay? And that's really the whole reason why we teach this intro course in C, because we want you to play with memory and get a sense of how memory works. And an array is basically like a decaying pointer. Again, I know those terms will not mean much, just let it sink into your mind for the next week. You can't return an array. You can return an element of an array, so I can return one item, but I can't return the whole array, right? I can't just pass it along and say, okay, I've made some manipulations and now I've returned it. As you can see in all of these functions, we're either voiding, we're returning an int. You can return a pointer to that first element of the array, because if you know the size of the array, then you'll know where it starts, you'll know the whole thing. Again, not going to make a lot of sense, okay? Pointer, decay, none of it is going to make a lot of sense. Don't worry, it will in week 5. For now, you can't return a pointer, okay? Just think of it as a syntax rule, just how you've accepted the ampersand as a syntax rule for now. It's coming. The explanation for it is coming. Okay, so let's do, I did have like a bit of extra stuff to do, which I thought there's a lot more that we can do, but I thought last week or last Monday people were a bit weirded out by enums and structs because we kind of covered them, and then I was like, well, I'm done with them. I don't really want to do them for now. So in your assignment, you're going to have to play with structs and enums, and we're going to do a big program next week in week 4 on Wednesday, or maybe it's week 5 on Monday. I can't remember when I've scheduled it, where we're going to have a much bigger program and problem that we're going to solve that's got enums and structs and all the rest of it. But I thought I'd just kind of write a little weird program really to demonstrate to you how you can have an array of structs as well and some enums. So I loaded it up in a very inefficient way as well because I kind of, also shameless plug for my other course, game design. Anyway, okay, so let's say I've got an enum, right? And the enum is basically game types. I didn't even list them all because I got over it. So I've got a few different types of games that I might have. And let's say what I'm doing is I've got this collection of games and I want to know which game in my collection is the most popular game. And they all have a rating for them. So I've got an enum that might hold the type of game and it makes it easier for me to enumerate them. And then I've got a struct board game. So I've got a structure that holds all the points of that game that I kind of want to keep as one, you know, as one structure, as one kind of collection of objects that relate to the same thing. That might not be the same thing. Shh. All right, the back row of this theatre. Please, 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 I beg you. I cannot keep yelling anymore. Thank you. Honestly, you can chat outside. I really don't mind. I don't mind if you chat anywhere else, but please, it really disrupts. The noise levels are too much. I'm yelling over you, people can't hear, and people online can't hear. Please. Shh. There's not that long left. You can do it. You can sit 20 more minutes in like a passive silence. Okay, so I've got a structure that holds the different things of a board game. And inside my struct, what I've done is one of the things is an enum that I'm holding as part of the structure because part of my board game definition is what type of game it is. So I've kind of specified, okay, I'm going to have an enum in here. I'm going to have an int holding a popularity score. I'm going to have an int holding an accessibility rating. And if you ever do my other course, you'll know that I'm obsessed with accessible games. And then I'm going to have, because we haven't learned strings, obviously this would be a really ridiculous thing to have char name initial. My goodness, every game, you could have many games with the same initial. It wouldn't really give much. We are going to learn about strings on Monday, so it is coming. And for the person that was like, an array of char is a really weird way to say string. An array of char doesn't necessarily have to be a string. So we'll learn about that next week. Okay, so I've structured my board game in a certain way, and then I've done, an enum, and really it's a way for me to now show you that I can have an array of these structures, okay? So because each board game is a struct holding various information about it, I'm going to declare an array of these board games. And it works in the same way. So the type is struct board game, and that's the type that I'm saying my array is filled with. And then I've got the name of that array, and I've given it a size. And what that means that inside this, at index 0, I have a whole struct sitting there, okay? And then at index 1, I've got a whole struct sitting in there. And then at index 2, I've got a whole struct sitting in there. So each index of the array actually holds a whole structure. I've got a bunch of information, not just a single int. I've actually got 4 things in each index that can be accessed in much the same way as you would normally access it. All right, this is a super inefficient way to load up this array of structs, but I had to do it somehow. So I've done a loop, and what I did is I accessed each of the structs. So to access an array of structs, to access an index, then what I've done is I've called the array name, which is game list. I've set it at index I, so in exactly the same way. Then I use the dot, and I've got, these are the variables that I can have as part of my structure. So these are the variables that I can, the members that I can access of the struct, and that means the first one is dot type. So I've said dot type and I've given it a name. So strategy is one of my enums. And then popularity score. So I really hated myself for doing such really long variable names. So dot popularity score, I loaded it up. Dot accessibility rating, I loaded it up. Don't worry about the stuff on the right side. It's really just random numbers so that I can demonstrate how the program is going to what it's going to output. Okay, so then I created another one. So this is really just loading up that array and initializing it. Okay. And then I wanted to show you that I can also print them out, okay, in much the same way as well. Okay, I would have whatever my array is at index whatever, and then dot whichever part of the struct I want to access, so dot variable name, and that gives me these values over here. What you can also see is I've broken up this printf statement, I think because someone has asked what happens if you've got a really long printf statement, you're going, beyond the 80 characters, who knows how far you're going. You can break them up and it will concatenate them. So just kind of move them in, both parts have to be in double quotation marks, and then it will bring them back together, right? Okay, so this is probably not the nicest way to do it, but in terms of style, but it's kind of showing you what's going on. I'll make this code available after the lecture and you can kind of play around with it. When we do code in the lecture, feel free to kind of copy the code over to whatever file is on your computer and change different things in it, like actually make it fail or, make it work, try different things. If we're doing it with ints, try it with doubles. It really gives you a lot of understanding of what's going on when you're trying to kind of work with it yourself and play with it yourself. Okay, and so what I kind of did here is then I scanned for the most popular, I scanned the popularity scores and I looked for the most popular one, so the one with the highest popularity score. And then I outputted it just for fun again. So like super inefficient, but it's basically a way to show you that you can have an array of structs. You can have it for something simpler. I don't know why I decided to have something with 70 ways to do it. So let's run it just so that you can see what it does, and it's not going to be looking that nice. Okay, I'm going to have to really kind of do that. Okay, so it's loaded it up. It's got game 0, type 1, popularity 0, accessibility. Then it's got game 1, and then I've got stuff for game 1, and then game 2. And then most popular game is game 2 because it's got a popularity rating of 8. And that's the one that it's outputted for me. So I was able to do that by accessing through an array of structs as opposed to just doing an array of ints. In your exam, usually the first question will have you playing with an easy array, but it might be an array of structs, who knows? And then further on, you might have much harder manipulation. So you have to be comfortable with all types of arrays. And if you do your assignment 1, you will be comfortable with all types of arrays. If you do it yourself, you'll be even more comfortable with all types of arrays. I guess I'll give that spill on Monday, but please, as the assignment comes out, at some point you might be very tempted to plagiarize something. Please don't. It's really important that you kind of learn yourself as well, because when it comes to the exam, you're not going to have a chance to really copy off anyone. You're going to be left on your own. No ChatGPT. No Google, no anything else, no other people. So please, 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 you get so much out of doing the assignments. And if if the temptation is really strong and you're feeling a bit desperate, because that's really most of the reason why people plagiarize is you don't know what's going on, please let us know. Please let your tutor know before you do it, okay? Because we can help you. Please don't just kind of suffer in silence. All right, Gab, can you ask if people would like to see a much simpler example of array of structs? I could have just done a series of coordinates, which would have been much more simple. The exam is not paper-based. You're in a computer lab. Okay, looks like we do. We really do. Like overwhelmingly do. All right. All right, let's do a really simple one then, and let's do coordinates. This is what happens when you do things at 2 a.m. You can't think of simple things to do. Okay. And let me make it available to you. All right, excellent. Okay, so, and let's do it from scratch, okay? So, what's the set of coordinates for? To find what? I don't know. To find a treasure. That'll have to do. And it's week 3, and it's lecture 6. Okay, I guess everyone is really happy with the start. stdio.h. Okay, so I guess we want to have a series of coordinates. So let's have a struct to hold our coordinates. So struct, I'm going to define it first. So struct coordinate. And inside this lovely struct coordinate, I'm going to have 2 things. I'm going to have an int x coordinate and an int y coordinate. Okay, so now I've defined it. I'm going to, in my main, declare and say that I'm going to be using it. So I'm going to say that I'm declaring that I'm going to use a struct coordinate, and I'm going to call it a coordinate coord. And actually, it's going to be an array of these coordinates. And there's going to be how many? Let's not get crazy. Let's do 3. Let's do 2 because we don't have all day. Okay, excellent. So struct coordinate, we've got the same coordinate, 2 things, amazing. So now let's load up some things into it, okay? We can scanf things into it. Do you want to scanf or do you want to just hard code some values in? What are we feeling? Scanf, okay, let's scanf things in. Okay, so I'm going to ask the person to do my scanning for me. I'm going to move through the indexes. So I'll go int I is equal to 0. And I've got 2 things in here, so that's a bit rude, bad style, hard coding. We'll go with that. Okay, so as I go through the indexes, what I'm going to do is I'm going to ask for a coordinate. So please enter an x coordinate. And I'm going to scan it in. And I could do them all at the same time, but not going to this time. Okay, so I'll do, and I'm going to put it ampersand inside array is called coord. I'm going to put it at index I because I'm moving along this index. And then I'm going to do a dot because it's going to go, I've got an x coordinate. It's called x coord. That's my member name. So I'm going to put it inside there. Okay. And then I'll do the same for a y coordinate. And I'm going to scan it in again. So I'm going to do a %d. And this time I'm going to put it into the array at index I. But this time my member is called y coordinate. So I'm going to move it into... No one's pointed out my spelling mistake. I was wondering why it's not lining up. There we go. Okay, so this will take me through and it will load up this array. But we really kind of want to see what on earth is going on in this array if things are correct. So that's going to scan things in. Now let's print things out. Okay, so I'll have a print loop. So int I again, I'm going to go until it's 2. And then I'm going to update my variable. And in here I'm going to print out I'm going to print them out like that because that's, and a new line for each one. And what I want for each one is I want to have an x coordinate and a y coordinate. So the x coordinate is stored inside the array at index I and inside the member x coord. And the other one is stored in the same array and in the same index, but it's stored inside y coordinate member. Okay, so let's see what this does for us. Okay, let's compile. Oh, amazing. It's been a while since that's happened. Okay, so let's run it. X coordinate 2, y coordinate 3, x coordinate 4, y coordinate 5, and then I've got my 2 coordinates, 2, 3, and 4, 5. Okay? I can also manipulate them in any other way that I want. I can add them, subtract them, do whatever I want to them, right? But it's the way that I'm accessing them that's changing when I have a struct, okay? In that I now not just have to have the name of the array and the index, but I have to let it know because each index has a few things sitting in it as part of that structure. So I've got to let it know which member I want of that structure that's sitting at that certain index, which is why I use the dot and I say where I'm going to load it up or where I'm reading it from. How is that feeling? Is that a much better example? I think so. The other one got a bit wild. Okay. Now, anything on the chat? Okay, nothing on the chat. Oh, how good's that? 5:46. How are we feeling about arrays? Thumbs up, thumbs down, thumbs to the side, thumbs up. So many thumbs up. Yes, yes, I like to see this. Okay, so Monday we are going to do 2D arrays and we're going to do strings. And I love strings. So, yay. Thanks, everyone. Have a great rest of the week.